So today we're going to discuss aerobic training or aerobic energy system. So this is one of the most complicated, and this one here I had to do a little bit of writing down in advance because there's a lot of numbers here to remember and a lot of words to make sure I spell them correctly and get my statistics as close to accurate as possible. So in the previous video, we discussed anaerobic, which is without oxygen. So that was whether it was ATP through creatine or then through the glucose. That was resulting in lactic acid or pyruvate and lactate accumulating. Now, this one here is what happens if we add oxygen. So the difference between anaerobic and oxygen and aerobic is with oxygen present. So this is going to be really interesting, and it's going to show you how important it is to have oxygen. So just like the last time, we start off with glucose. So glucose is what we've had ingested. We may have had some intracarbs, we had some simple carbs, or we've had some rice or potato and bread, and it's broken down through the amylase enzyme into glucose, and that it is in the bloodstream, and then that glucose gets stored as glycogen in the muscle, just as last time we discussed. So glucose is stored in your glycogen stores, which are all these little storage places in all of the muscle. So you have glycogen stores that hold the sugar, but we don't actually use glycogen. We free it up back into glucose, and that glucose is then used as energy. And in the last one, glucose turned into pyruvate, and then because we had no oxygen, we couldn't go down here. We started to accumulate lactate, and remember, it got up to that 4 millimole line, which is the millimole, the amount of lactate in the blood where we hit the lactate threshold. So quite commonly, if you think about going for a run, you'll get to this point and then you'll start to back off. And what's interesting happens when you back off, all of a sudden you feel like you get your second wind. And this is what's so exciting here. We're going to look at that, what happens now, because when we can have oxygen, when we introduce oxygen, so we're operating at a lower intensity where we have enough oxygen, because remember, this accumulated because we couldn't remove the hydrogen ions building up. There was too much hydrogen building up in the blood, become too acidic, and eventually we fatigue. So now, if we can add oxygen, oxygen allows us to create something really, really cool, and that is acetyl coenzyme A. So let's write that here, ACE-CoA. So oxygen converts pyruvate to acetyl coenzyme A. We don't convert glucose to that. Glucose is converted to pyruvate, so it needs to go bang, bang to here. But acetyl coenzyme A can be created also from amino acids and fats. So this is where we start to get into something really, really cool. With acetyl coenzyme A, we enter what we call the Krebs cycle, or the citric acid cycle, also known as the Krebs cycle. It's got a few other names, but these are the most common terminology, citric acid cycle. And this is a process in which we create different forms of energy. Or remember, we're always trying to create ATP. ATP is the only form of energy we use, but how we build it, how we make ATP, we can get ATP from fats, we can get it from protein, we can get it from glucose. So what's interesting here, when we create this, we still only have 2 ATP through glucose. In the mitochondria, we have something called the electron transport chain. And through that process here, we create 36 to 38 ATP. So in here, we've got 2 ATP from carbs. We've got 36 to 38 through the ETC, electronic transport chain. Then adding fat, once we have a single fat molecule that comes into the citric acid cycle, creates 129 ATP. Wow, that's huge. Then we also produce NADH and FADH in here, and the NADH creates 3, and here we have amino acids, creates 30 to 40 depending on the amino acids. So when you consider that in your diet, when you're using protein, when you're eating a high amount of protein, protein can become a usable energy. So if we're consuming a super amount of protein, we can use that protein to become energy. And if we're using protein as energy, maybe we won't draw as much from the fat stores we have. So consuming over an amount of required protein can keep us from using the fat as an energy. But that's nothing to really consider too much about, because I mean, most people tend to consume too little protein. But when you consider what's happening in this rotation here of the citric acid cycle, it's really, really fascinating. NADH, as we see here, creates 3. But the more NADH we have, the more ATP we can make. So you've all seen NADH as a supplement sold on the market these days. So consuming extra NADH will actually be extra ATP. Excuse this, I have to close this low battery thing there. Okay, so taking NADH will mean that you can have more energy in the citric acid cycle. So taking NADH supplement will see that you have more ATP. Fats, one fat molecule becomes 129 amino acids, ATP. And then taking amino acids, 30 to 40. So consider what happens now when you're going for a run, and then you find your rhythm, and then some people say you hit your second wind. It's not the second wind is that you've now gone into the citric acid cycle, and all of a sudden, boom! Look at that. It's close to 200 ATP in a run revolution. That's a lot. That's a lot of energy. First, you were operating with 1 with creatine, and 2 with glucose in the lactate system. But now with oxygen present, all of a sudden we've got all these potential ATP. So when you're slowing down, and you can breathe, you're going to be burning or creating so much more ATP. And obviously that ATP is coming from these substrates. So we want to use our fat. This is how we burn fat. This is literally how we burn fat. So we can talk about all these macros. Fat turns into ATP. That's what we want. If we want to lose weight, we need to have this fat become ATP. So we have oxidative phosphorylation, which is what happens in the electronic transport chain. And the pyruvate oxidation is turning pyruvate into acetyl coenzyme A. So these are the other words I've listed here. So these pretty fancy pants talk, but the main takeaway from this is if you slow down and you don't feel the burn and you allow yourself to catch your breath with oxygen, you can produce acetyl coenzyme A using fats, using amino acids, and then the citric acid cycle shoots out nearly 200 ATP. That's amazing. So look how many ATPs fat yields. So having a high fat diet should actually see you have quite a lot of energy. But say you're on a keto diet, you will probably gas out quite fast in the anaerobic system, and then you will thrive in the aerobic system. So people with a higher fats diet would probably be better off doing a bit lower intensity training, and with a high carbohydrate intake, you will have a much better high intensity training. So you just have to be aware of that. So considering your carb timing, taking carbs pre, intra, post will add to the training intensity. But if you're on a keto diet, you'll probably notice that you don't have the same intensity in a set of bench press. So you'll still get the 10 seconds using creatine, but you won't get the same from the 10-second to the 2-minute mark intensity, because you'll anyone that's competed in bodybuilding sees in the peak week, you really struggle to do those sets and reps because you're not operating on any carbs. Well, some people carb deplete, and then you'll notice that you have no staying power. But then fast forward to after the show, and now you're piling in the carbs. Wow, what a rebound you get. So we can discuss peak weeks and rebounds another time. But for this session, we're talking about how pyruvate turns into acetyl coenzyme A, and amino acids and fats can turn into acetyl coenzyme A, and the citric acid cycle, which includes the electron transport chain, creating 36 to 38, 129 from fat, 3 from each NADH. I think it's 2 from every FADH. Amino acids 30 to 40. So there's a huge benefit of getting into the citric acid cycle. So now I've done that, I'm going to rub this out, and you can always go back and pause and take some notes, because another thing I want to discuss here is the efficiency in which you train. And you may have heard the term oxygen debt and oxygen deficit. That is, say if I was a robot and I was walking along and then I wanted to run, then my energy demand goes straight up. I do my running and then I go back to walking. So it would be pretty much high amount back to low amount. And if I was a robot, there wouldn't be any kind of lag there. It's just like automatically turn up to this intensity, drop it back to this and recover. But now as a human, we know that we have to do the anaerobic phase first, which is without oxygen. So this is us getting up to the point in which we're going hard. So this here is where we were too low on oxygen. This is oxygen that we were really deficient of, that needs to be repaid in equal a proportion after. So now when you finished your run and then you stop, you take equally a long time, or the equal amount needs to be paid back. The recovery time can actually be improved, and how fast you repay this oxygen based on how fit you are. So the more unfit you are, the longer that will take. I've seen someone that's not used to running, they can be breathing heavy for a long time. So this is what we call oxygen debt and deficit. This is the deficit we had. This is the debt we need to repay. So considering now when you go for a run, when you start running, then you're 100% on creatine, on stored ATP and creatine. That has no byproduct. You're cool. And then you need to start creating ATP through glucose, and then that is still a high yield, and that can take us for 2 minutes. So we could be running along here for 2 minutes, and we could potentially be doing that entirely anaerobic. And that's without oxygen. So here is that oxygen that we didn't have enough, that we had to repay. Now, most people, though, when they go for a run, they won't just stop. They'll start their jog, and then they get to this point, and this is the 2-minute mark or so, depending on your fitness levels, and then you start to slow it down, and then you go to your, it's a bit dramatic there, and we start to go over here, and this is our baseline. So this is us jogging for a sustained, so long steady state cardio. So we're not actually stopped. Now we're jogging. We're not at this high intensity. We're at a moderate intensity. So we are also paying back our oxygen here, and then we will continue to just jog at a good pace. This is us getting our breath back. This is our active recovery. This is us recovering whilst still performing. Now, the citric acid cycle that we discussed, we burned fat and amino acids and lactate and all those things in the citric acid cycle. We can liken it to a washing machine. We throw in all the crap. In one revolution, boom, nearly 200 ATP. That's like, it really, you should be like mind blown on that. It's so cool. So when we've done this, when we've slowed our intensity down and we've introduced oxygen, because here we've added O2 because we can now decrease our intensity, and now we become aerobic. We are now able to breathe, and through this adding of oxygen, which is creating acetyl coenzyme A, we now feel like this could go forever because we technically have so much stored energy. Remember, 129 from fat alone, one fat molecule. And you give yourself a good hard look at yourself and think, how many fat molecules do you have in your body? I mean, the average person contains quite a lot of fat. So imagine how many ATP stored energy they have. So getting into this aerobic phase, we have a really long energy supply. This one here is finite because we can't operate at a high intensity for more than, say, 2 minutes before we start to back off. The aerobic phase, we can go for a long, long time. Now, maybe we don't actually get up into this anaerobic phase. Maybe we only just start going for a jog here. We don't go up to here. So now we don't even really need to pay any oxygen back, but it's just the way it is. We still have to go through that phase where we had oxygen. We didn't need oxygen. So we have created this deficit because we didn't need it. But we use this. We have to go through the substrates in that order. So now we just jog forever, not forever, but yeah, for a long time. And then we are cruising along now with all those ATP. And when we come to the end of our workout, we will still pay it back. This is fat burning zone, amino acid burning zone. This is where people would say around 60 to 80% is your fat burning zone. Anything over that is your anaerobic. It's your carbohydrate burning zone. So when you're operating at this rate here, this oxygen rate, this is where we'll target the fats we have. So all the fat we've got stored, that will become our fuel source for that workout. If we are going to do bench presses and squats and the heavy high intensity training, our main fuel source is glucose there. So even though people say that, I don't want to say this wrong, so anaerobic training is carbohydrate based because oxygen is not present, and then going and doing cardio training, that's fat burning. If you want to burn fat, then if you want to use fat as a fuel source, you need to keep it at this intensity. You can't be up here. But then your fat burning is only pretty much here, because after you stop and you pay back this, you're back to normal. So fat burning occurs here during the exercise. If we're doing high intensity training and we stop here, depending on the form of training, or maybe say like a hardcore leg session, it can show that thermogenesis is elevated. It can be up to 72 hours. So not that we're paying it back over 72 hours, but we actually take in more oxygen for a long time. And we have, here is us burning fat. We're still burning fat. This is our baseline. So when if you trained legs super hardcore, you will have a high fat burning. This is fat burning. In between here, this is baseline, and we are still burning fat when we have baseline as well. So not to say we need calories just to survive, we need energy to survive. But if we're elevated from our baseline, this would be us burning fat all the next day, all the rest of the day, all the day after, because we have trained super intense. So high intensity will actually have a high amount of fat burning post exercise. And what they call that is EPOC, exercise post oxygen consumption. So EPOC is highest after, obviously, intense training, because if you're cruising along here, there's very little oxygen needed because your oxygen wasn't deprived. Here, if I was doing, imagine doing like a 2-hour leg session of one minute sets of squatting and leg pressing, and having a 1 to 2 minute recovery between sets. So we're getting enough ATP rebuilt and we're removing the hydrogen ions enough, but the intensity is so high and we do it for a sustained time, the exercise post-oxygen consumption could very well be elevated for 3 days. So what you have to consider is there is fat burning training, there is sugar training, but when do you want to burn the fat? Is it during the workout or is it after the workout? So after the workout, you can be burning fat for many, many hours, but you have to train hardcore. So some people actually drink like Gatorade or carb drinks whilst they're doing cardio, because when you're doing anaerobic cardio, so high intensity interval training, you're using the better you train high intensity, the more oxygen you will consume post workout, the more fat you will burn post workout using the citric acid cycle. So we're going to come back to this another point in the future, because this is something that we need to understand, and we can relate it back to our diets and when we discuss the way to set up a diet. But I really wanted you to understand the acetyl coenzyme A's ability to use fats, amino acids, lactate, and how carbohydrates, all of that enters the Krebs cycle. And humans are amazing when you think about it. I mean, we are built to survive. And if you're smoking, you affect your oxygen consumption. You're basically strangling yourself by compromising your oxygen uptake. You're preventing oxidative phosphorylation. So, make sure your breathing is on track. Try to keep your lungs nice and fresh, and taking supplements that improve oxygen. So, the pre-spray we made, that helps with oxygen through having better blood cell, having no rouleau, having no blood cells stacked on top of each other. That will in turn aid in fat burning, because you have much better oxygen use. So we can discuss next time VO2 max and how and those sorts of training. But for this session, the most important part was to discuss the Krebs cycle and how amazing it is. Thank you for that.